talking about polygons. This is the start of chapter 8, which mainly deals with parallelograms and quadrilaterals, but the first section is on all polygons in general. So a polygon is a closed plane figure with three or more sides that are all straight. So let's break that down. For a figure to be closed, it has to connect. So something like this is not a polygon because it's not closed. Okay, three or more sides that are all straight. Okay, so if we look at these figures here in A, these are all polygons that are closed. The sides are all straight. There's three or more. Okay, but let's talk about concave versus convex. I always think of concave. Look, it's caving in. Okay, so if you look at A, these are all convex figures. Nothing's caving in. If you look at B, these are all concave figures. There's portions that cave in. Okay, so recognize the difference between convex and concave. Okay, let's look at these. See if you can identify which ones are polygons, which ones are convex and concave. Take a second, push pause, and think about it. Okay, hopefully you can see that this is a concave. Don't worry about the whole irregular. Polygon. This right here is a convex regular polygon. This one is not a polygon. The sides are not straight. There's not three or more sides. We have a circle there. This is a convex, right? Irregular polygon. Once again, don't worry about the irregular or regular for right now. And this one is not a polygon because it does not connect. Okay, let's talk about how we're going to find the different measurements in these polygons. So the polygon interior angles theorem says that the sum, so all of the angles on the inside of the measures of the interior angle of a convex polygon is n minus 2 times 180, where n represents the number of sides. So how many ever sides you have, subtract 2 and multiply by 180. And that will tell you how many degrees are inside the whole figure, the sum of all the measures. And then this is just a little side theorem down here. The interior angles of a quadrilateral always sum to 360. I'm going to assume we know that though. So let's take a look at a problem. It wants the sum of all the measures of the interior angles of a convex octagon. So ask yourself, how many sides does an octagon have? It has 8. So n equals 8. So we're going to take 8 minus 2 times 180. So 6 times 180 tells us that all of the angles added together total 1,080 degrees. Done. Okay, this problem says the sum of the measures of the interior angles of a convex polygon is 900 degrees. So this time it's the reverse. They gave us the total angles, or the total degrees inside. We want to figure out how many sides. So we need to figure out what is n. So if we take the above formula, the n minus 2 times 180, this time it's equal to 900. So now we can solve for n. So the way I would do this, recognize that n minus 2 is being multiplied by 180. So to undo multiplication, we can do division. So if we divide 180 over, we get n minus 2, because these canceled out, equals 5. Add 2 over, so n equals 7. There are 7 sides in this figure. Now, you can always check yourself. Take 7 minus 2, which is 5, times 180, and it does indeed equal 900. Okay? Let's take a look at these two. It says find the measure of the missing angle. Well, let's first figure out how many degrees are in each of these figures. So if we look at this figure, there's 1, 2, 3, 4 sides. We know a 4-sided figure has 360 degrees. So if we take 360 degrees and measure out all 3 of these angles, subtract those guys out. I did it in my calculator. I don't remember what they total. But if we subtract those 3 angles out, what's left for x is 72 degrees. try the bottom one. The bottom one's a little trickier though because these are congruent. So push pause and let's see if we can figure it out. Okay, so there are 5 sides in this figure. So if we want to figure out how many degrees there should be total, we take 5 minus 2, so 3 times 180, and we see that there are 540 degrees total. So if we subtract out these 3 angles, okay, there are 206 degrees left. Now, there are 260 degrees left for these 2 angles, but recognize they're the same angle, they're congruent. So let's call those x's, so 2x equals the remaining 206 degrees. So x is simply going to be 103 degrees each. Once again, you could check. If you fill those in, each is 103, and then add these up, do they come back to our total of 540? Yes, they do. Now, normally this is an activity I do in class, but clearly I'm not going to be there tomorrow to go through this with you. So the idea behind this next theorem is that if you look at all of your exterior angles, so all of these exterior angles, 1, 2, 3, 4, and 5, okay? And if you were to cut them out, okay, cut out the exterior angles. Clearly we're not doing this because I'm not going to be in class tomorrow, okay? Clearly, if you cut them all out and you line them up, they're going to total 360 degrees. Think about a triangle, okay? If I put some exterior angles out here, okay, and I tell you this is 60 degrees and this is 70 degrees and this is, hold on, what's left in our triangle? 50 degrees. Okay, they add up to 180 degrees in a triangle. Okay, this guy, we can figure out because it's its supplement is 120 degrees. This one, because it's its supplement, is 110 degrees, and this is 130. If we take the 120, the 130, and the 110 and add them up, we're going to get 360 degrees. The sum of the exterior angles of any figure always add up to 360. Say you don't believe me. Let's look at a quadrilateral here. I'm going to draw in some exterior angles here. If my board were aligned, this would be a little better. Let's say this is 50 degrees and 50 degrees. I'm just making these values up. And these were each 130. Okay? This supplement would be 130, 130, 50, and 50. Once again, the sum of the exterior angles always add up to 360, no matter how many sides you have. You can try lots of other figures, but just believe me. Okay, so the exterior angle theorem says that the sum of the measures of the exterior angles is always 360 degrees. Let's try some practice problems now. It says find the number of sides. So we're looking for n of a polygon with an interior sum. So all of the inside angles add up to 2,880. So remember our formula, n minus 2 times 180 equals the interior sum. So let's fill in. We don't know n. We know our interior sum is 2,880. I want you to push pause, take a second, and solve that, just like before. Okay, hopefully you divided by 180 and got n minus 2 equals 16. Add 2 over, so n is 18 sides. Okay, the next one says find the interior angle, so one angle, not the sum, of a regular heptagon. Well, let's see, a heptagon has 7 sides. I think some people call it a septagon too. I feel like I've heard that along the way. Okay, so let's figure out all of the interior angles first. Okay, so if we have 7 sides and we subtract 2 and multiply by 180, we can find that there are 900 total degrees. Now, earlier I said we'd come back to the idea of something being regular. If something's regular, that means all of the angles and all of the sides are the same. They're congruent. So if we want to figure out one angle, We know since there are 7 sides, there should be 7 angles. So if we take all of the angles added together divided by 7, now this is an ugly number, it's okay. Each angle is approximately 128.6 degrees. Divide the whole sum by the number of angles, 7. Okay, go to the next slide. Find the interior sum. So this time we want all of the degrees inside a 15-sided polygon. So we know n is 15. So let's do 15 minus 2 times 180. And we get 2,340 degrees. So there are all different ways we can phrase these problems, but it's all coming back to this n minus 2 times 180. Okay? The next one, find the measure of the exterior angles. So all of the exterior angles, or the sum of the exterior angles. What did we say? Don't be tricked by this. What did we say the sum of the exterior angles is always equal to? 360 degrees. No work required. Done. That's easy. Last 2 examples here. Each exterior angle, so each exterior, so that's one exterior angle, not the sum like last time, of a regular polygon is 24 degrees. Find the number of sides. So let's take a second and think about this. We have a regular polygon, so all of the exterior angles are 24 degrees. Well, think about it. Didn't we say there are 360 degrees total? If we divide that by each of the angles, shouldn't that tell us how many angles there were? Which is the same as how many sides there are. So if we take the total of the exterior divided by one of those exteriors, it should tell me how many of those angles or sides there's going to be. So 360 divided by 24 equals 15 sides. Okay, the last one. The interior angle of a regular polygon is 120 degrees. Find the number of sides. Once again, we're looking for n. And we have one interior angle, not the sum. This problem can be done in 2 ways. I'm going to show you what I think is the easiest way. Okay, when I return on Tuesday, I will show you the other way. Okay, if each interior is 120, that means each exterior is what? Okay, you have to know that the interior and the exterior angles form supplements. So each exterior is going to be 60 degrees. Okay, so just like before now, we know there are 360 degrees total in the exterior. Divided by each of the exteriors, it's going to tell us that there are 6 angles, which is the same as the number of sides. So 6 sides. Once again, I'll show you the other way. I think this is the easiest way. So there's lots of different things we can solve for with these polygons. Okay? Please make sure you took down great notes. We will pick up with this stuff tomorrow. Have a good day.